Hello, and welcome to Controllers Tech. This is fifth video in the Ethernet series, and today we will cover the TCP client mode. Here the STM32 controller will be used as the client, and it will communicate with the server, which we will create in the computer. So let's start the video, and I will directly go to the main file. You can check the connection part in the first two videos of this series. Here is the main file, and I will start with the ping test first. You can see the same code is being used, which we have used in all the videos till now. Ethernet if input calls the appropriate function, based on the type of the packet received. That's why we have been using the same code for all the protocols so far. Let's test the ping now. Alright, the flashing is done. This is the IP that I set up in the CubeMX. And it passed the ping test, so we are good to go ahead. Now include the TCP client library files. Let's take a quick look at the source file to see some important functions. I took the example provided by the ST, and modified them a little here. If you have watched the TCP server video, you will see a lot of similarities here. These are all the functions that are being used. Most of them are similar to the TCP server functions. I have created a periodic timer callback, just like the UDP client video, and this function will be called every second. Here are the steps to implement a TCP client. Create a TCP block, connect to the server, and start communicating. To create a TCP block, we will use the same function, TCP new. Then we will connect to the TCP server. Here first we will convert the server IP address in the integer format. This is the IP of the computer, and you can check it by typing ipconfig on Windows command prompt. Finally, we will use TCP connect to connect to this server. Let's use some random port, later we will create the server with same port. Once the client is connected to the server, this callback will be called. Just like the TCP server, here also we will initialize few other callbacks. We are mainly interested in the receive callback, which will be called whenever the server sends some data to the client. We will check it in a while. The timer callback, which will be called every 1 second, here we will send some data to the server using the function TCP client send. When the server sends some data back, the received callback will be called. Just like TCP server, this function has some predefined code to handle the errors, but we are interested in this part, if the state is switched to connected. Here, first of all, we must acknowledge the data received. TCP received function is used for the same. Then we will call the client handle function to handle the received data. And in the end, we will free the buffer. Let's see the client handle function now. Well, I am not doing anything special here. I am getting the IP address of the server, just in case if you need the IP. And in the end, increment the counter. This counter variable is being used in the timer callback function. Here I am sending this message to the server, which will send the updated counter value. So whenever the server sends some data, the counter will increment. Otherwise, this callback will keep sending the same counter value every second. We will allocate the memory to the buffer using pbuffalloc function. Then copy the data into the payload of the pbuff. And finally send the data to the server. In the end, we will free the buffer. Let's build it once to check for any errors. We have few warnings, but that's alright. Let's write the main function now. First we will start the timer interrupt, so that the periodic callback can work. Then initialize the TCP client. We also need to include the header file for the TCP client. Alright, let's build and flash it. I am going to use the Hercules for the TCP server. Here I have used the port 31, so let's listen to the same port. We can check the status here in this window. Let's run the code now. We got the client connection success message. Here you can see the client sending data every 1 second. The counter is 1, because we are not sending any data to the client, and this is why the client handle function is not being called, and the counter is not incrementing. But as soon as the server sends some data to the client, the counter will increment, and you can see the updated data sent by the client. And again, we can see the updated data. Let's see the process of execution. Here I am setting a breakpoint inside the client connected callback. One inside the receive callback. Another one inside the sent callback. And one last breakpoint here. Let me clear everything first. Let's run it now. As soon as the client got connected to the server, we got a hit inside the connected callback. Another hit in the handle function. This is because we are calling the client handle function inside the connected callback. Now after the client sends the message, there is another hit inside the sent callback. You can see the messages are being sent to the server. Let me remove this breakpoint. Okay, now we will send some data to this client. Here we got a hit inside the receive callback. This function will call the server handle, and now the counter value will increment. The connection got disconnected for being idle for some time. But I think you got the idea of how this works. This is it for this video. I hope you understood the working for the TCP client. We were able to send the data to the server, and receive some data from it. You can download the code from the link in the description. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.